Hello and welcome to this online video lecture about Lewis acids and bases. The Lewis theory of acids and bases is the broadest. It applies to the most situations, chemical reactions, and it's probably the most advanced. You won't really be using the Lewis theory of acids and bases a whole lot unless you go on to further study chemistry in college or later on in life. Be that as it may, if you want the 10 points for this advanced quiz, you need to be able to look at compounds and reactions or outside of reactions, figure out which ones would be Lewis acids and bases or not, and identify how they would react with each other. So let's look at how this theory of acids and bases works, and we'll see if you can get this stuff figured out. Let's first start off with some definitions of what makes something a Lewis acid or base. According to the Lewis theory, an acid is it's an electron pair acceptor, and the base is the electron pair donor. So this Lewis theory is about electron pairs, and that's really important because it's a lot different than some of the stuff that we've been talking about in the past. So we're not talking about single lone unpaired electrons. Now we're actually talking about electron pairs. And that's really what kind of makes these Lewis acid-base reactions different from other kinds of chemical reactions, is that there's an entire pair of electrons that's getting donated from one chemical to another. So let's take a peek at a reaction, and we'll see if we can get this figured out. We're going to start off with a pretty classic reaction. I'm sure if you do a little Google search, you'll find this one fairly easily. But if you take ammonia, which is NH3, and you react that with a chemical boron trifluoride, and this is what you have. Now, you have to kind of go back to one of the things you learned in the first semester, which are these Lewis structures. So if you think about nitrogen, it's got 5 valence electrons. So to make ammonia, the hydrogen forms a shared pair. Each hydrogen forms a shared pair with the nitrogen, and then there's this unshared pair up here. Now boron is a different deal. It only has 3 valence electrons. So to make boron trifluoride, you've got the boron, and it's only got the 3 valence electrons. And then when the fluoride comes in, it forms a shared pair with its one lonely unpaired electron that it has. And so you get this. Now, here's where it gets kind of interesting. Sorry, I kind of messed up that pair there. Let me fix that. Now I better erase it. Do it again. I don't want anyone to be confused. What's interesting about this is if you look at the boron, it basically has room in its electron cloud. It's got a spot in its electron cloud where there could be an electron pair, and there isn't. It's basically completely empty. And that's kind of the key here. In order to have a Lewis acid, it has to have some space, a minimum of one spot in its electron cloud where you could stick a pair of electrons. And that's exactly what we see when we have a compound like boron trifluoride like this. There's a spot here where you can stick a pair of electrons. So what electrons are going to go there? Well, it's this unshared pair of electrons right here in the ammonia molecule. So basically what's going to happen here is that when these two compounds come together, these 2 electrons are going to be donated by the ammonia to the boron trifluoride. And the 2 molecules are basically going to start sharing them together. The boron and the nitrogen are going to start sharing those electrons. And so you get this giant complex molecule, basically. You get the boron trifluoride. I'm just going to draw lines here. Boron trifluoride, how it was before. Oh, fluoride, not. Oh my gosh. And then it forms a bond through the shared pair of electrons with the ammonia, which is kind of like this. It makes like this big, weird, complex molecule. But that's basically what's happening. This is a Lewis acid-base reaction because the ammonia is donating its electron pair to the boron trifluoride. And so what that means is it makes, the theory says that the electron pair acceptor is the acid. And so that means that the boron trifluoride is the acid here. And it says that the electron pair donor is the base, and that makes the ammonia the base. And so that's basically the Lewis acids and base theory, and it can apply to a whole bunch of different chemical situations. So let's look at another fairly common example or a situation here where you have an electron acceptor and an electron donor. We're going to look at ammonia again, but first we're going to look at some kind of a metal ion. So let's say, oh, I don't know, we'll say a zinc 2 plus ion. And we're going to react that with ammonia, which we saw before. Now, just like before, ammonia has that spare pair of electrons just kind of chilling, right? It's got that unshared pair that's going to chill in there that it can donate to something else. Well, in this case, it can donate that to the zinc because the zinc had 2 valence electrons, but because this is a zinc 2 plus ion, those valence electrons are gone. So this zinc doesn't have one spot in its electron cloud where it could put a pair of electrons. It has 4 because its valence shell of its electron cloud, that top electron cloud is basically empty. And so what that means is the ammonia can basically come along here and it can donate its pair of electrons to the zinc, and it can go into one of those spots. But since zinc has 4 empty spots, it's not just going to be one molecule of ammonia here that's doing this, it's going to be 4 of them. And so what you'd end up with is a zinc ammonia complex where you've got basically ammonia coming off from all 4 sides of the zinc like this. And this is a pretty common Lewis acid base reaction. So what's the acid and what's the base when these metal ions react like this with things with electron pairs? Well, let's reflect. Let's go back up real quick. See, so we got the zinc, and then all of these, before we look at that, all of these right here, those are all electron pairs that were donated by the ammonia to the zinc, right? So I made the little circles over here. See all these, there's like these all 4 empty orbitals in the zinc's electron cloud, and the ammonia can take its electron pair that's not shared and it can donate it to the zinc, and that's exactly what happens, and it makes this big complex of zinc and ammonia molecules. It's kind of weird. So let's just kind of review our definitions and see if we can figure out which one of these is which. We'll go back up real quick. So the acid is the electron pair acceptor and the base is the electron pair donor. So what's happening with our electron pairs? It looks like the ammonia is donating its electron pair to the zinc. So that makes the zinc the Lewis acid, and it makes the ammonia the Lewis base. So what you really need to take from this is that under the Lewis acid-base theory, the acids are electron pair acceptors and the bases are electron pair donors. That's what you really need to take from this, and that's what you need to be able to apply to example compounds and reactions to try to figure out which is which. So that's the basics of the Lewis acids and bases theory. Thank you for watching this video lecture, and as always, if you have any questions, please ask in class.